All right, I've got a question, number 13 from lesson 3. This is a two-part question here. First of all, they want you to show that both lines contain the point 1,4. The second one's find the angle of intersection. So I'm going to call this part A and part B. So part A is finding that point, and part B is find the angle of intersection between the lines. All right, so part A, how do we go about finding whether they are in fact an intersection point? What I would recommend is, I'm going to take that first line and 3, 9 plus t, 2, 5. What I'm going to do is I'm going to switch it to parametric, or we can leave it in this form as well. I'm just going to substitute the point in. So if I substitute the point 1,4 in for the left side, we end up with 3, 9 plus t, 2, 5. So now I'm just going to look at the x component. So the x component would show me that 1 has to equal 3 plus 2t. My y component, I'll do over here, would be 4 equals 9 plus 5t. So what I'm going to do is I'm going to solve for t in the x component. It doesn't matter the order here. You can do the y component first. I'm going to subtract 3. So we end up with negative 2 equals 2t, or t equals negative 1. I'm then going to do a substitution into the y component. And we should find, actually, I don't want to do a substitution. We can do a substitution, but I'm not going to, just the way I have it set up. I'm going to subtract 9 from both sides. So we end up with negative 5 equals 5t, negative 5 equals 5t, and t equals negative 1. So this shows me that the point 1,4 is definitely on the first line. Now I'm just going to repeat the process for that second line. And it's the same thing. Your t values should always be equal to each other, if that's the case. So the next one was r equals negative 5, 6 plus. You'll notice they changed variables for the direction vector. If you have two different lines, you can't have the same variable. So notice we had t over here, and now we have u. So whenever you jump to a new line, you have to have a new variable. So keep that in mind if you have to create a new equation. So in this one, do the substitution again. And I'm just going to use the exact same method. U, 3, negative 1. So my x component would be 1 equals negative 5 plus 3u. The y component is 4 equals 6 minus u. That kind of looks like a W or some random shape that I've decided to create. There we go, that's a little bit better. Solving for u, I'm going to add 5. So I have 6 equals 3u, u equals 2. And on the other one, take away 6 from both sides. Negative 2 equals negative u, or u equals 2. Now notice that you don't have to have the same, the u and the t value do not need to be the same. They just have to be the same, or the u and the u values need to be the same for that particular equation. So that tells me that therefore the point 1,4 is on both lines. Now we have a bit of a throwback question here. B says, find the angle between the two lines at the point of intersection. Well, it doesn't really matter where we pick the line, because in the end, we have a direction vector facing one way, and we have a direction vector facing another way. So really, we're just finding the angle between two direction vectors. So the angle between two direction vectors. And if you think back to your last unit and on the test, how would you do that? Well, the easiest way is the dot product. All right, so u dot v equals magnitude of u, magnitude of v cos theta. So doing my dot product with my vectors, I'll do this off to the side here. So we have 2, 5 dot 3, -1. So that would equal 6 minus 5, which is equal to 1. So I know u dot v equals 1. The magnitude, so I'm going to cheat a little bit here and just put it all into the equation. 2 squared plus 5 squared times my v vector, square root of 3 squared plus -1 squared, cos theta. Doing a little bit of simplification, 1 would equal root 29, 9, 10, root 10, cos theta. So cos theta would equal 1 over, that one's something I can do in my head here, 1 over the square root of 290. So that tells me that the angle is the cos inverse of 1 over square root of 290. So there gives you, that's the angle between the two lines. And like I said, it's based on the angle between the two direction vectors. Don't need to find lengths or anything like that. Don't have to create triangles. So we can just use our properties from the first unit. If there's any questions with that or any follow-ups to that, let me know, and I'll be glad to give you a hand.